Welcome everyone. I've started work on overhauling my AC engine for my 1949 2-litre Saloon. This is such a fascinating engine design that I will devote this first engine video on its history and development. Also what my plans are to repair and upgrade my engine. This AC engine was produced from 1919 until 1963. It was designed by the brilliant John Weller during the First World War. It was a very advanced design. It was a lightweight straight six with an alloy block and sump. It featured wet cylinder liners. The cast iron head was a cross-flow design and had a single overhead camshaft. The valves were slightly inclined with a part spherical combustion chamber. Not quite a Hemi, as our American friends would say, maybe a semi-Hemi. John Weller left AC cars in the early 1920s, but the design developed quickly. It gained an extra main bearing, making it a 5-bearing engine with 2 of them at the rear end. This involved a separate extension piece, or adapter piece to use AC's term, to the back of the crankshaft. This adapter piece included the sprocket for the timing chain, which is at the rear of the engine. The crank had to be in 2 pieces to allow a bronze skew gear to be installed towards the rear, which drives the cross shaft. This cross shaft in turn drives the dynamo and distributor. If you're wondering why these ancillary drives are at the rear end, it's because a long crankshaft has more torsional vibration, making it unwise to have any gear drives at the front. Belt drives are okay, and chains work with careful tensioning. Weller's original design had a skew gear and shaft drive for the camshaft. Now with a chain drive, a very simple tensioner was devised, in fact amazingly simple, a strip of spring steel, and AC patented it. It works and never seems to wear out. In the 1930s the engine gained a set of triple SU carburettors. After World War II the engine mountings were spread wider to permit rubber mountings. A new water pump was designed to mount on the side of the block, pumping coolant into the engine. This allowed a lower bonnet. Unfortunately, this pump was not well designed and became a weak point for reliability. My dad experienced 3 pump failures during 12 years. However, problems can be minimised by assembling an overhauled pump meticulously, ensuring that the carbon seal can move freely and seats evenly. As with most problems, there are also design improvements that can be made. There is one issue of this engine's later development that I've never read anywhere. This is just my own opinion. I believed it received minimal development after the war because AC were working on a new flat 6 engine. That project took over 10 years before being abandoned. If you read up on the old AC straight 6, you will see that they did uprate it more for the Ace and the Asika sports cars. I wrote an article for the AC Owners Club back in the 90s about the engine's shortcomings relative to other post-war engines. The way the engine is bolted together in the highly stressed areas, such as big ends, and the sealing with gaskets was looking pretty old-fashioned by the late 1940s, let alone by the early 60s. I believed that these problems could be resolved to improve reliability and durability. The AC engine was gaining a bad reputation in its old age, as gaskets under and over the cylinder liners gave trouble and alloy blocks corroded internally. Now to describe some of the upgrades. The main purpose of these upgrades is to make the engine more durable and reliable, and also easier to overhaul in the future. I also decided to give myself a challenge to greatly improve fuel economy. This was before the fuel prices shot upwards this year. I don't need high horsepower, although more mid-range torque will make the car more drivable on the roads. I don't have the new parts yet, so for now I'm showing you images of the original parts from my engine. The first upgrade is the crankshaft. This is a 1-piece shaft. To get that bronze skew gear on, and the mounting for the flywheel has been made much smaller. The journals and pins are slightly larger to run in metric thin-wall shell bearings. The original bearings were thicker bronze-backed shells that have to be white metal line boards scraped in, etc. The original big ends were direct white metal rather than having shells, so the new conrods will feature modern shell bearings. The original flywheel is a two-part damper flywheel. A damper at the rear is pretty useless. It won't fit the new crank anyway, so I'll have to fit lightweight flywheel. I'm apprehensive about a lightweight version, but it is not ultralight, weighing in at about half the original. The original was about 30 pounds or 14 kilograms. For torsional damping, later AC engines had a metallastic damper at the front end. These reduced the peaks of resonant vibrations. Over the years, rubber deteriorates. A fluid damper could reduce these peaks much more and also smooth out the peaks. This can extend the life of main bearings. A UK company called Tip Top Engineering sell a fluid damper for older classic and vintage engines, and it looks much more discreet than modern dampers. New wet cylinder liners are slightly modified to take more modern thin gaskets under them. The new improved head gaskets are a complex composite construction. The original gaskets were copper asbestos both over and under the liners. With all this beefing up, it is then feasible to increase the compression ratio substantially. This ties in with my fuel economy challenge, as the efficiency will rise. Also, less heat will go to the cooling system and exhaust. Pre-war engine designs did not have oil filtering. The AC engine has a gauze filter to prevent sludge blocking the oilways. The oil is kept relatively clean by having a large capacity sump to act as a big sediment bowl. The fine metal dust sinks to the bottom of the sump, ready to be flushed out at regular oil changes. This is every 2,000 miles on the AC. In the early 50s, AC added a bypass oil filter. This thoroughly filters the oil, but it takes several hours of running to get all the oil through. When upgrading the engine, it's important to add a modern full-flow oil filter. It is also important to do the installation correctly, with a pressure relief valve downstream of the filter and the pressure gauge showing the pressure feeding to the bearings rather than the higher pressure ahead of the filter. Another big upgrade will be a shiny new alloy head. The engine is very tall and carries the heavy iron head high up. Apart from saving weight, it has several subtle design improvements. The combustion chambers are equal, unlike AC's originals. There is improved lubrication to the overhead cam. No doubt the gas flow has been enhanced too. There are a few common misunderstandings about the pros and cons of an alloy head. The most significant is its effect on volumetric efficiency. That is, how efficiently the engine can draw in air-fuel mixture during the induction stroke. Compared to cast iron, aluminium alloy conducts heat much better. That provides more heat to the induction passengers, and this is where confusion arises. Some people claim that this heats the charge and reduces volumetric efficiency, but that is not so on a petrol engine with carbs. The extra heat causes more petrol to evaporate, and its latent heat cools the charge. The only moment that the actual temperature of the charge matters is just before the inlet valve closes. With ethanol in modern fuel, the effect is even better. Alcohol has about 3 times the latent heat of petrol. The AC engine is not as sensitive to fuel variations as other older classics. I'm also fortunate that it is fairly simple in its construction. For example, the Jaguar XK engine is far more complex. I'll cover more about the alloy head advantages in a future video when I get to work on the new head. Hopefully these upgrades will bring out the full potential of this 103-year-old design. I weighed my engine, including all minor fittings but excluding the clutch. It came to 362 pounds versus the 350 pounds that AC claimed. That is 164 kilograms. That includes the silencers that are mounted on the manifold, the ignition system, hoses, etc. No cheating. With the alloy head and lighter flywheel, it might come down to about 310 pounds or 140 kilograms. The original power output is quoted as 76 bhp at 4,500 rpm. Redline is at 5,000 rpm. New anti-surge valve springs are good for 6,000 rpm, but I don't plan to test them to their limit. Original maximum torque was quoted at 105 foot-pounds at 2,750 rpm. I'll be raising the compression ratio all the way from a lowly 6.7 to a modern 10.7. AC experimented with 11 to 1 on a Saloon, but settled on 9 to 1 for the later Aces. One extra bonus of the new crankshaft is that you can install a single-piece modern rear oil seal. I don't want Jay Leno making jokes about oil dripping on the garage floor. I will need to work out how to make and install a suitable seal housing. I also need to design a new crankshaft pulley, as the old one will not fit the new shaft. The new pulley will also double as a mounting adapter for the fluid damper, so there's plenty to attach the little grey cells. I hope you will enjoy seeing more videos on engine progress, and I hope that progress will not be too slow. Thanks for watching.